So I want to welcome everyone to the second virtual webinar of the year for STEM Lyceums. We're going to be talking about STEM and policy, so quantitative decision-making and policy decisions. The Center for Excellence in Education was founded in 1983 by Joanne DeGeneiro and Admiral Rickover. And the center's mission is to nurture high school and university scholars to careers of excellence and leadership in STEM, and to encourage international collaboration between and among global community. So we have 4 cost-free programs at the center. There's the Research Science Institute at MIT, where students go on for 6 weeks to study and live and pursue coursework. Then we have the USA Bio Olympiad. So this is open to any high school students. It's a series of exams and tests that explore your knowledge of biology concepts. So anybody who took the USA Bio exam yesterday, congratulations. The top 20 go on to attend the national finals, and then the top 4 go on to attend the International Bio Olympiad. The teacher enrichment program is a part of CEE where teachers explore connections with industries and academia and make meaningful professional links with students. It's really similar to STEM Lyceums through virtual webinars. And then we are a virtual club for high school students. We meet once a month to explore STEM concepts and career pathways. We have an opportunity for students to apply to be STEM ambassadors. It's just a way to engage really closely with what we talk about during our webinar sessions. And they offer places for career planning and to explore cutting-edge research professionals. So as we did with the previous webinar, we're going to have a question and answer session. So after the speakers, there's a time for you to put questions into the chat. And I'm going to welcome our speakers. So we are going to start out with Tim Profeta, who's a faculty fellow from the Nicholas Institute, and Cecilia Hedman-Younger, who is a professor from Yale University. And then we're going to transition to Anne Schellinger-Jones. And if I said that out of order, I will kind of just pass it over to Tim and then transition from there. So I'm really excited for this webinar. Thank you so much, Anne. Tim, you can share your screen.
Thank you, Erica. Let me just get up here. And really, flattered to be asked to speak with the students today, and hoping to be helpful. I am, talking with Erica and others about this. I've been working in environmental law and policy now for over 2 decades, and as I'll sort of describe to you, I've worn a few hats. I've been a lawyer. I've worked in the judiciary. I've worked in the Senate. I'm now working in the executive branch. I've also worked in the university setting on this. And but what I thought I would do is actually run through sort of my career a little bit and touch on issues throughout that where STEM issues were sort of at the fore in the work I was doing. And in doing so, give you sort of more of a landscape view of all the various ways in environmental law and policy one sort of interacts with STEM fields, and how STEM fields can plug into them in whatever work you're choosing to do later in your career, rather than sort of having just some narrow inquiries of the too many specific things. So that's what I'm going to try and do. I'll try and sort of get a lot of stuff on the table and leave a little time for Q&A. I apologize, but I'm going to have to leave at 5, so I think we're going to do a little quick Q&A for me before I jump off, and hopefully still you'll find this helpful. Now, there we go. So I'm just going to sort of talk. I really am going to talk about this chronologically through my career, with apologies for the sort of like, it does feel a little bit weird talking about myself, but I want to start. The first, when I got out of college, I was a political science major. I was not a science or engineering major. But I knew I wanted to work in the environmental field. So the first thing I did is I worked for the NRDC, which is one of the major Natural Resources Defense Council, one of the major environmental groups in the country. And one of the really interesting things about the NRDC is they have in their hallways economists, biologists, chemists, lawyers, all these various disciplines, and who come together to try and sort of problem solve for the environmental challenges. And so I got exposure to the sort of the full ecosystem of environmental policy there. Spent time working on pesticides, particularly looking at pesticides that would be what they call have immunotoxicity, with sort of class of pesticides that would knock out people's immune systems, and also working down in Capitol Hill on legislation to reform what was called the Super Fund, which was a big government fund to clean up toxic waste sites, and assessing what is the acceptable level of risk we could ask people to suffer through if they were living where these toxic wastes had been disposed. So I went working at the NRDC. I actually decided I wanted to be a lawyer, but I wanted to be a lawyer who was fluent in science, because what I realized working there was that attorneys do have a lot of the role executing on the environmental issues, but they needed to be informed. So I went back to school, and one of the things I think to introduce here is that you don't have to. You can go to school and work across these various areas of study. I went to law school at Duke, but I also went to the Nicholas School of Environment, and I got a degree in landscape ecology and learning sort of the biology of large ecosystems. And from that, I was able to sort of have one inform the other, which I think was really sort of fascinating approach. But I did come out and I did start practicing law, and I went pretty immediately to a court system, and I became sort of the in-house lawyer for a federal judge making decisions. But even in that role, which is pretty purely legal, the biological science that I had studied at Duke was coming to the fore. And we had two cases, just as examples there, where groups had sued the federal government saying they were not adequately protecting key species in our country, in our ecosystems. One was a lawsuit against the Forest and the Fish and Wildlife Service of the United States, saying they were not preserving the land appropriately to protect the grizzly bears in the northwest of the United States. And there I was able to draw on my knowledge of concepts like, from my master's program, concepts like connecting habitat, these islands of habitat, into sort of a network so that the bears had enough area to have their life functions. I was able to draw on that and observe the arguments that are being made in the court to sort of help decide what these bears needed to be protected in their endangered status. The other case was a case down in California for this little critter called a fairy shrimp that's down in the lower right. Fairy shrimp it's a little shrimp that lives in freshwater pools that are vernal, which means they're only wet in the spring, and then it kind of goes dormant and it pops back up. But the agriculture community was plowing up all these fields, and they were going to make the fairy shrimp go extinct. And you may say, why do we care about one little critter when we need to, and that's a very valid argument. But actually, the way that the law works in this regard, the species are a signal that the whole ecosystem is troubling. And if the species are going extinct, the ecosystem can be going in trouble. And so I was able to appreciate the ecological threat that was being posed here, and why the statute was being the statute to protect it was looking at the shrimp as a sort of signal of a larger problem in the ecological system. So even in a courtroom, the STEM issues were kind of need to come to the fore when you're working on environmental issues. Next step is I went to work in the U.S. Senate. I worked on the Senate Environment Committee, and there no longer was I reacting to people coming to the courthouse and suing, but actually I was trying to create new law. And I picked 4 examples of like 1,000 places where science and then technology and engineering were mathematics were absolutely essential to what we were doing. The image in the upper left is an area called Long Island Sound. I was working for the senator from Connecticut, and we wanted to do ecological protection of that sound in the estuaries and all the ecological functions they gave the state of Connecticut. So we drafted a major piece of legislation to allow for the sort of updating and adaptive management of that ecosystem. Created a lot of funding for it, but also guided the strategy by our knowledge we had of the ecology and the biology of the system. We also wanted to sort of drive innovation, and so when our office led in the creation of this thing called ARPA-E, which is now a big agency inside the Energy Department that's a very front end, early stage venture funding of engineers and innovators to help them innovate for new energy technologies. And we kind of studied what it took to make really innovative engineering places thrive, like things like the RAD lab that created radar in World War II, and the Manhattan Project that led to the nuclear bomb. What was it made those things really innovative, and try to take those lessons and take them to the energy thing. I was involved in a major fight over whether to allow drilling in northern Alaska, and that little red dot on top of Alaska, that's called the Arctic National and Wildlife Refuge, where there's a lot of oil under the ground, but it also has a herd of 100,000 caribou that go through there every day, or every spring they migrate through. It's amazing ecosystem, and so we had to sort of bring those environmental values forward with sort of showing how essential that ecosystem was for basically the whole northern part of Alaska to thrive. Lastly, I was really pleased to be, pleased is a strange term, really excited to finally get the Congress moving on climate change, and there's no topic more central to our environmental law and policy right now than climate change and how to start solving the problem of concentrations of greenhouse gases in our atmosphere, and I'll get a little bit more into climate, but in our office we wrote some of the first bills to address the climate issue when I was in the Senate. But I left the Senate, and I left Senate because actually I got this really fascinating offer to go back to where I went to school, to Duke, and build an institution that whose job it was to try and create solutions, it was right there in our name, for environmental problems. And this institute we built brought together people from all over the university's campus. So we would bring the Pratt School of Engineering faculty together with the business faculty, together with the biologists or the water hydrologists, or whatever the issue was. We would sort of be able to sort of go around the university and bring together these teams with expertise in how to solve environmental challenges. And it is a sort of candy store of sort of thinking and intellectual activity. I just picked 3 examples of the many things we did. I ran that institute for 16 years, so we tried to solve a lot of environmental problems and even managed to move the needle on a whole bunch of them. But just a couple of things, just to kind of give you a little variety of the sorts of STEM-related questions we were into. We would have to get into. In the lower left, we were asked in a place in Nevada to create a water trading program. This means that the water was running out in this agricultural area, and they needed to find a way to give the right to access to water in a way that would be more sustainable. And the way they wanted to do that is they actually want to use economics and create a market where if the water is more valuable, people would take more care to not use it and keep supply up. But what they really needed to know first was what the watershed hydrology of, exactly how is this watershed working? Where's the water coming in? Where is it going out? What are the sort of how permeable are the soils? How much are you going to lose through? So we had to actually do a lot of sort of water science work to make sure we knew kind of what the budget of everything that water this place had was before we could do any of the economics to tell them how to conserve it. Another project I'm fascinated by was we were really trying to figure out in Africa how we could bring power to people in these rural villages, very poor villages in all across what you call sub-Saharan Africa, the whole area underneath the Saharan desert, where there was just, rural, poor people who were just kind of getting left out of the world economy. And we were able to work with engineers to design these solar home systems, just basic solar technology, but designed in a way that was engineered to be really user-friendly and usable in these sort of thatch housing areas. We were able to actually build businesses in deploying these all across Africa, countries like Kenya and Tanzania and Rwanda, in a really, but it was really that first engineering of what that product would be that made it a doable thing. And the third example I used was actually we had an effort working with fisheries managers. So the people who are charged with telling fishers how many fish they can take out of the seas in a way that's sustainable and allows, ensures that we don't overfish and lose our populations in the oceans. And we would have like about twice a year meeting with these fisher managers up and down the east coast of the United States. And one thing they were seeing was that the ocean was warming, and they needed to understand that maybe they didn't need to do a plan for species X, because all that fish knows is they like colder water, so they're going to swim north. But actually now they needed a plan for fish Y, for another type of fish that had come swimming up from Georgia to North Carolina. And so it was a really, I think a really valuable sort of exercise was to work with our oceanographers and our climate scientists to understand what was the changing patterns of warming in the ocean, and how is that changing the fisheries, the fish distribution, so that actually the policymakers knew, what they should be doing, what species they should be looking. Also wanted to sort of pull a couple examples, not just another sort of array of things, places where STEM plug in the environmental policy, things I've done that weren't my day job, but things I've served in advisory roles on. The logo to the upper left is something called the Climate Action Reserve. This is a group out in California, and it's an incredible application of sort of science to drive positive change on climate. What the Climate Action Reserve does, and it was founded by the state of California, is it creates what we call protocols, but it creates very specific approaches to count how much greenhouse gas reductions you get if you do certain types of projects. And then if you use the protocol from the reserve, you're then able to get paid for doing those greenhouse gas reductions by people in the market for these things that's in California, or just companies that want to be doing something good. Like if you fly in an airline, people want, Delta or somebody will ask you, do you want to offset your emissions? Well, these are the sort of projects that are making reductions that are supposed to account for what you created in greenhouse gases when you flew on your Delta flight. So in that role, that is completely bound in whatever the science of the natural system that we're talking about. So if we're talking about, a project to take a cow farm, a dairy farm, and stop methane, which is a powerful greenhouse gas, from coming out of their waste, that's actually, there's a lot of biological science and then chemistry to make sure we know how to control for all that methane. And if it wasn't for that grounding in STEM, you couldn't create any of these assets that people are willing to pay for. Top right is a company I advised for 10 years, it's actually a little bit like what I said earlier that RPE was trying to create. It was a mad sort of bunch of mad scientist guys from MIT who had gotten together. They all had sort of retired from their jobs, and they're trying to create engineering solutions to the world's problems. And one of them is this company called Net Power, which has changed how one might generate power in a turbine system. Right now, what you do to generate electricity in a turbine system is you heat you burn natural gas or something, it creates heat, creates steam, the steam drives the turbine, spins electromagnetically, creates electricity. They changed it. They said, let's not use that anymore. Let's actually burn it so it only creates CO2 and drive the turbine with the CO2 and then capture all the CO2, which is the greenhouse gas. So they proposed this plant and they think that if it works, it will actually be able to generate electricity with all the pollution captured, which is kind of one thing I told them they have to stop talking about it. They have to build the darn thing because it sounds too good to be true. But they're now running a sort of a mid-sized one outside Houston, Texas, and so far it is actually working. And lastly, I was sort of really honored to serve for the AAAS, American Association for Advancement of Science, on the committee they have on how to bring science and policy together. One of the things I really loved that I worked on there was, how do we get more scientists in the policies? And that we ran the program that's called the Fellows Program, where we bring people who just got their PhD in some discipline, all heavy scientific disciplines, and we bring them to Capitol Hill or we bring them to the federal government, and they're allowed to serve for a year or two and learn what the policy side of the street looks like. Last thing I want to say is, where am I now? I'm now at the US EPA. I'm a senior advisor in the Office of Air. I'm actually still an employee of Duke University. I've just been loaned to the government. It's a full program. You can loan professors into the government. Another way to get scientists into the policy world. My job is to help write regulations for the power plants, and we're in the process of actually producing 3 or 4 regulations to try and reduce pollution from the power plants in the United States. And the entire inquiry is based in engineering. I mean, most of my time is spent with really, really whip smart engineers who are assessing what works, because the way that the law is written, it says you have to require people who run power plants to put the best system that's been demonstrated on the plants. Well, that means we have to go in with really good engineers and find out what's worked, kick the tires on it, make sure it's working before we make anybody else do. We don't want to have them trying to deploy a failed technology, and then that finding generates the sort of standard we can hold people to. So that's what becomes our regulation. So I'm spending a lot of time now with the engineers of EPA on that question. So I think that's about the time I want to give and then to talk, and then I want to make sure I was available for some questions. And hopefully that smattering of experiences triggers some things for you as students, of like things that particularly interest you, or maybe that's a career path I didn't think of before. I could work on it from this framework. So that was my goal, and I hope it was helpful. So Eric, I'm going to pass back to you to see if we have any questions.
Thank you so much, Tim. I think that's such a wonderful exploration of your career journey. And if we don't have students who are taking AP Environmental Science right now, we're going to after this webinar. So that is really cool. We are going to give a chance for people to ask questions for Tim before we go on to Anne. So far, Terrence asked, is the program you were just speaking about only for PhD students? I'm assuming he was talking about the Nicholas Institute.
No, I think he was talking about the AAAS Fellows, which is the program that we were working on, where you were allowed to get fellowships onto the Capitol Hill or into the executive branch. And that program is just for recent PhD graduates. There are other programs that place people in the fellowships from other places. A lot of them, the other one that when I worked on Capitol Hill, we used to engage with a lot, was one that the Brookings Institute ran, that placed people from executive branch, the executive branch side of the government, into the legislative branch. But that would be a pathway where if you didn't have a PhD, but you had worked a couple of years at the EPA or the Interior Department or Ag Department, that you could then go in.
I want to give students a few more minutes to come up with questions if they don't have. Do you have recommendations for specific major tracks for students who are interested in either pursuing environmental policy or in just working in the environment, starting as undergraduates at university?
Yeah, that's a great question. First of all, I'd like I like to encourage people to have to take classes across disciplines. Just like I said with the institute or a couple places in my career, none of these challenges are solved from a single discipline. You can engineer the most beautiful solution, but if it's not doesn't make economic sense, or if it doesn't get people politically willing to do it, it's not going to be utilized. You need to be able to bring together all these areas of knowledge. So I would encourage you to take an array of classes that sort of show you the issue from many different lenses. There's a lot of really good environmental science programs now out there in the universities, and they're really well designed. But there's also just core biology majors, core chemistry majors that also will get you there. But I like the idea of mixing up some of the hard science with something like political science or the like, which will give you a little bit more of that understanding of like the human side of how to get people to act to address the problems.
I think that's phenomenal. I did political science and anthropology, and some of my favorite courses were doing environmental science courses in college and biology. So that's really, really cool. So it's 4:56. The questions seem to be more so focused on the program you were just talking about. I know that you have a few more minutes with us, so I want to give people a chance.
Mm-hmm.
What was your favorite experience? Because you talked about a wide range of things. You worked in academia, you worked at the Senate, you were doing consulting. What was your favorite experience out of all of those?
The answer I would cheat and say is I like that I did them all. I like that I actually was thinking the other day with my role at EPI, I've now worked at an interesting level and all three branches of government. And I like that I have the perspective across those branches. But if you're gonna make me say what is my favorite of all of them, I think the favorite of all of them is building that Nicholas Institute at Duke, because that was something that that you had the feeling of an entrepreneur, that like we went from having kind of a glimmer in our eye and a clipboard of ideas, and we built something. And that just there's a pride in that, and building something that I like to think helps society. So there's a feeling of pride in that. I think that's probably my favorite piece of the whole puzzle.
I think that's really cool. That's awesome. Being able to tap into the entrepreneurial spirit and then also doing something for the environment. I love that. And I really, really appreciate the advice of making sure to explore interdisciplinary avenues when you're looking at a college and career pathway, because I think that's really going to help students kind of broaden their horizons of what, when I think of STEM and policy, I wouldn't necessarily think of environmental policy, but it's one of like the core foundations that we need to actually make meaningful change.
Great. I'll say this right now. I think we're at the forefront of a world of opportunity to be able to do things that are entrepreneurial, that are going to help the environment and help society. Like we were talking right before we came on, Erica, about how just this year with passage of a number of pieces of legislation, there is a massive investment going on, not just with the government, but in response to the government's actions. Banks and the private sector and investors looking to find things like businesses they can invest in that would reduce greenhouse gases and make a lot of money. And there's all sorts of entrepreneurial activity in the area that's really exciting. And if you think about that little experience I had with that company, Net Power, those guys were just almost in their garage inventing a new thermodynamic cycle. Now they just use them. They just did a public offering on the New York Stock Exchange, and their company's valued at $1.6 billion. And if it works, they're solving the energy problem because they can create energy without any pollution.
Yeah,
So,
I think that was one of the more exciting things. My brain kind of went ding when you mentioned that company.
yeah.
Because it sounds like science fiction, but it's not. It's something that's it's realistic. I mean, we can accomplish that. And so that's a really cool application of STEM skills.
Yeah.
Well, thank you so much, Tim. This was really interesting. I want to pass it over to Anne Schellenberger-Jones, who is going to talk to us. I was going to finish that and then I just cut out, my brain cut out for a second. But thank you so much, Anne. I really appreciate it.
Okay, all right, I have control now. Let me go ahead and share this. Sorry, I'll apologize too, because it's crazy, but I never use Zoom. I always, for work, we just never use it. So are you seeing the full presentation? Or are you seeing
You're sharing your screen, but I can see the speaker notes.
Yes, let me find the swap then. Yeah, I know. I actually even looked up the I was like, if you know offhand how to, I know there's like the swapping. Nope. All right.
I'm wondering what would happen if you maximize your screen, or if you clicked at the very top where it says present from the beginning, like slideshow.
Yeah, I'm in. So I see the slideshow on I just need to swap monitors. There's usually like a swap monitors button, and I didn't. I just need to. All right. Did that do it? No.
Yeah.
Are you seeing the full screen now?
I can see that it's just a slideshow in PowerPoint.
You still see my version. You don't see my full screen version that I'm staring at on my screen, do you?
No, we don't see that. If you exit it and try to reshare your screen, it might work this time.
Yeah, let me just exit.
Taught in Zoom. So at least with webinars, you can't tell if like it's working now.
Oh, I paused it while I made the changes. Okay. Sorry about that. Yeah, no, I actually always use I use Teams and Google Meet for work, and we never use Zoom. So it's the one thing I don't get to see that everyone else has all the time. So let me start a little bit about myself then. Yeah, so I'm Anne Schellenberger-Jones. I've been involved with the Center for Excellence in Education since 1990, when I actually attended RSI. So what I'm going to talk about today, again, maybe apparently policy and environmental is maybe the theme of the day or something. So I'm going to talk about the work that I do in environmental damage assessment and kind of how my STEM experience integrates with real world decision making and policy folks. So I'll talk about the types of situations we face, the regulatory and legal systems that we work under, the types of questions we need to ask, like how we think about going forward with our work, and how various scientists and economists and lawyers all kind of end up working together to get the answers that we need to solve problems. I'll tell you a little bit more about my origin story, kind of how I ended up here, and also kind of some thoughts, hopefully, that are helpful about finding your own path. If this is the sort of thing you're interested in, there's a whole lot of different places that STEM kind of interacts with how we make decisions about the world. Then depending on it, here we go. I'm a partner at a niche consulting firm in Cambridge, Massachusetts. And if we have some time at the end of the presentation, if I didn't use it all up, unfortunately, I'm messing up the screen share, I'll talk some about the work that my partners do as well, because we have a wide variety of, kind of science and policy fitting together. So hopefully by this point, most of you have figured out what this is a photo of. So this is the Norfolk Southern derailment that happened just over a month ago in East Palestine, Ohio. And so I'm going to talk about some of the examples of the types of, basically, when do we get called? When do I start talking to people? What are the sorts of things? And so this is your kind of, disaster of the week crime. If this were a disaster of the week crime procedural, this would be our, disaster of the month. This would be our photo. So I'm going to talk some about the different types of things we see, what they are, and how that kind of drives the sorts of work that I do. So I think too, at this point, you probably know a bit about this. One of the main things here too is that this particular case was a release of vinyl chloride was probably the main thing you've heard about in here. So a number of the rail cars, a lot of our hazardous chemicals are transported by rail. This causes a lot of issues around the country, around the world. This was a particularly kind of bigger situation than usual. The main thing was there were several tanker cars full of vinyl chloride. As I said, it's used in the manufacture of PVC. So those white pipes in your home, all that stuff like that uses it. Very reactive, thermally unstable. And so in an event like this, they had, for a variety of reasons, they had a buildup of pressure in one of the cars. This is one of the big things that happened, was they then had to, basically, in order to prevent what they felt was going to be a explosive fire, they poured it out into a pit and burned it, which created these, it's not actually what you're seeing in this photo, but, kind of vast clouds of smoke drifting, Ohio, Pennsylvania, the whole, there's a kind of wide variety of affected things. We're looking, you can kind of imagine there are things happening in the air, there are things happening, there's, chemicals on the ground, there's chemicals getting into the water. There's been reports of fish kills, people worried about what's being deposited in their fields, what's the air like in their homes, when can they go back to their homes? So this is just kind of the most recent example at a big scale of the types of things that we deal with. So here, there's all kinds of different things that can happen. We see this in so many forums. This, this comes from the fact that as a country, as a people, we do a lot of mining. So we want gold, we want silver, rare metals, their jewelry, what powers our Tesla batteries, our laptops need them, and sometimes things go wrong. So this here, in 2015, an EPA contractor was investigating ongoing acid mine drainage that was happening at a gold mine and a whole complex of mines actually in Colorado. And they accidentally breached a kind of large reservoir of acid mine drainage that they did not realize was actually at the level that it was. Hundreds of thousands of gallons of metals contaminated water flowed out. It went down the Animas River through Colorado, which is where this photo is taken, then went into New Mexico and Utah when it hit the San Juan River, affecting a large number of communities. And in particular, one of the things that issues there is the San Juan River runs through the northern border of the Navajo Nation, the largest, kind of independent tribal nation within the United States. And the San Juan River is kind of one of the sacred rivers for the Navajo. So this was a kind of a huge just environmental and social disaster. Sorry, there we go. Another big one you've probably heard about, the Deepwater Horizon oil spill. So again, if you're, given that the audience is high school students, I realize you're probably pretty young when this happened, but maybe something that you've also heard about. So this led to one of the largest oil spills that has happened, and this went on for months. So an oil rig exploded, several people were killed. And then they couldn't figure out how to stop it. So oil was gushing out into the Gulf of Mexico for months. Somewhere there's an official legal agreement that it was 3 million barrels, but maybe up to, there's a lot of uncertainty in exactly what that estimate was, but at least enough to fill 300 Olympic-sized swimming pools with this, and kind of oil ended up throughout the entire Gulf of Mexico. So Texas through Florida, through the Florida Panhandle, is kind of the area we're talking about being affected there. It's also ships we deal. So this is the Casco Busan. We're in San Francisco Bay in this case. So an intoxicated pilot failed to properly understand his radar, and they crashed into the Bay Bridge. That's what you see. So there's that lovely, this kind of 100-foot gash in the hull of the vessel, almost 60,000 gallons of fuel oil. So this was just a tanker ship. They're not it's a cargo ship. They're not an oil tanker, but they obviously carry a large amount of fuel just to get where they're going. And disrupted recreational fishing, commercial fishing, uses of, San Francisco is a pretty active area. Pipeline spills are another thing that happens that we end up seeing a lot. We see this is, the cleanup situation. We've got people out in Tyvek cleaning up bags of trash, taking care, putting out this boom to protect different habitats. And this is just what we see along this sort of thing. Fish kills are another big problem that we come across. This is a cyanide spill that happened in a tributary of the Danube River in Hungary. So again, a very, very kind of some famous international locations and things that are affected by these. Oiled wildlife and, the kind of impacts of chemicals and oil on wildlife is definitely one of the kind of biggest public scenes for this sort of work. So this is from the Deepwater Horizon oil spill. And we know, this is what we know. We know that wildlife are affected by these. And then we have a whole, can we bring them in? What can we do about it? We know, this is, for a while there were kind of ubiquitous commercials for Dawn dish detergent and things to clean wildlife. And they still do. That's what they do. This is those suds that you see there. That's probably still Dawn. But yeah, they have to clean birds one by one. So you can imagine that this does not, how do we do it? So, but we know this is what we do. We've got processes, we've got a whole rescue system kind of set up to deal with these. And seeing these, and again, you have to think about whether maybe this is what speaks to you and maybe it doesn't, but having seen all this, it always, it made me wonder, like, how do we fix it? How do we make people whole again? How do we prevent this from happening? How do we make up for dead fish and oiled birds and ruined marshes? What do we do as a society? How do we figure out how to move forward from this? And it's not just these immediate spills and things like this. There's, if you read the news, you're aware that there's what they call forever chemicals, these fluorinated compounds, they're in Teflon, and they're in the line, and they're in liners of food packaging sometimes, or they're what coats your carpet and makes it stain resistant. And the reason they work is because they're really unreactive and they stick around forever. So they end up in our groundwater, they end up in our soil, they end up in our fish that we eat. There's a whole lot. And so all of these different things, what do we do about it? How do we solve these types of problems? And that's kind of what got me to where I am right now. And I'm going to talk, and the main thing, this is where it starts to integrate the science and the, kind of, and all of the things that happen, they need to happen in a legal framework. You need to have a set of rules that you can follow to figure out what you need to do about it. And the two big things at the federal level that we can do about it are CERCLA, which actually So you heard it kind of briefly in the previous presentation about the super fund. So its official name is, this mouthful here. And Superfund is the cleanup part, in particular for kind of long-term industrial pollution and things. But there's also kind of a big compensation part to it, which is the type of work that I do. And then similarly, that's for a certain set of hazardous chemicals that is actually an official designation. So the EPA has an official designation of what hazardous chemicals are. And those are the only things that you can bring suit for under CERCLA. Oil is separate. So that's covered under the Oil Pollution Act. And it has similar kind of compensation regulations to it. Then there's also a whole set of state environmental regulations that may or may not address what do we do about kind of damage to the environment from different events. And then kind of going on, I'm going kind of from like federal law towards like the private litigation sector and things. So in addition to having kind of state regulations, states, tribes, cities, they can also use tort law and just the general legal system to address claims against to address kind of environmental damages that have happened to them. And then individuals have the right to be plaintiffs in their own suits or in class action suits and bring cases against companies that have released chemicals, or things that have happened. So, and then additionally, kind of outside of here, there's a whole set of international law that we can work under and that we do things with. The Berne Convention is something particular to Europe, but has to do with how kind of the movement of the protection of species and the rights kind of species to not be destroyed. And then there's various international courts that can happen, and the United Nations also works on this at times. We've worked for kind of compensation commissions and things that they've put together to deal with environmental damages, particularly from war or aggressive actions. So a little more detail about how kind of what this is that we do and kind of this framework that we're working under. So most of the work that I do is at this federal level under kind of that Oil Pollution Act and CERCLA. And it brings three main things to the table to have these sorts of frameworks. It brings money that there's a known process for how these things get paid for, and that it is the responsibility of the party who, what we call responsible parties or potentially responsible parties who, created the problem, that they are financially liable for not only the cleanup, but also for taking care of every, kind of the losses that happened while things were destroyed. These types of laws also set up people. They figure out who's the plaintiff. Because if you've talked at all about legal system, there's somebody has to make a claim. Somebody has to have what's called standing to say, I think this is a problem, I'm going to sue you, I'm going to hold you liable for this. And what these do is they say that the government can act on behalf of the people and on behalf of just the natural resources themselves, that's their job. And then it also says that it's very specific then about what they have the right to do, that it's not just cleanup, it's not just responding to the incident and cleaning it up, but that that for this period of time when resources were lost, that you get compensation for that. So, and there's a whole kind of science and process that is built up around this, that's a marriage of economics and natural sciences, that's called natural resource damage assessment. And one of the key things that it does do is provide this, what we call compensatory restoration. So that basically, because you lost things for 20 years, it's not just enough to clean it up. Like, it's going to take a long time for things to get better. And so you don't have to just clean it up. You need to give us compensation for that 20 years when we didn't have those birds, and that fish population got decimated, and it's going to take a long time to recover. All of those problems like that are also covered under these statutes. So this is where the science part of it really kind of comes into play and what we do. we're solving puzzles. We're putting together stories. A lot of it is just kind of building up a, kind of building up a universe of what happened, and how bad was it, and what do we need to know. And there are a ton of different ways to get involved, and kind of a ton of different sets of expertise that are all part of this. So we want to, we need to know all of these questions about what happened, and we have all of these people who have their jobs and their expertises, and they all come together to kind of work on these sorts of things. So I'm going to step through a couple of these, to kind of give you a sense of what this looks like. So that first thing about, so, and most of these, actually, I'll just say of it, these are mainly from the Deepwater Horizon oil spill. It's just a very, anyway, it makes it very easy to show kind of some of these examples, because it was a very large case. They spent a lot of money on doing things. They did it right. They worked very hard, and it's all public. So it's very easy to kind of show you the type of work that happened on that. So fate and transport is a big part of what we do. This is modeling. This is kind of the marriage of math and science, of what likely happened, where did it go, how much of it was there. So this in particular here, we're talking about the contaminant levels in the sediment around this spot here, this Macondo well. That was where the initial wellhead was. So that's the rig was built up above that wellhead. That's where the big fire was, and that's where the oil was gushing out at the seafloor. So this is kind of putting together maps of where contaminated sediment was, and then where the oil was on the surface over a time period. So you can see too, I mean, this is, 100 miles of the Gulf of Mexico here. We also spent a lot of time putting together conceptual models, trying to understand how all the pieces fit together. So environmental science and ecology, that sort of work teaches you a lot about systems and how they interact with each other, and how they're touching each other, and what's really happening and things. And so we spend a lot of time thinking about how all of those pieces touch together. So in this case, this is the shoreline on the Gulf of Mexico, but we have the wellhead, we have oil spreading out. It's down on the seafloor. It's up on the ocean. Parts of it, they applied dispersant to it, which again, another set of chemistry we have to think about. What are these dispersants? They try to break up the oil so that it doesn't coat things. We saw the pelicans. We saw those sorts of things. But so they apply dispersants so it's not as thick and gooey. But then it turns out, well, I mean, but you end up getting a lot of it still kind of there, and it becomes this additional kind of particulate matter and things floating through the water column. So we spend a lot of time on this, because this tells us exposure too. This tells us we're trying to figure out, like, what could have been touched by this, where all did it go, and what sort of things do we need to be worried about. We spent a lot, then there's a lot of this that is actually just out in the field measuring things. So these are transects. Well, sorry, these are plots along a transect. Like we take a whole long line of these to look at and see, how areas that were oiled, how the vegetation that's there responds, and how the organisms that live in the sediment in the marshes are affected. So in this case, we've got a reference location and a heavily oiled location. Probably pretty obvious that they look a little different from each other. But in addition to kind of counting, so it's counting the stem density. How many stems do we still have there of this marsh grass? Are there still periwinkles, these little snails and things like that live in the, so you're counting all of these different things, and you're comparing areas. So that's like these little, and actually these are PVC made from that vinyl chloride we talked about back in the first slide. But each of these is the same size. So you're going around because you want to be very consistent so that you have, kind of basically the way, it's science. Like, we need to know that we're measuring the same types of things in each place. We spend a lot of time counting, like I said. We count dead things, we count live things. We like to count more of the live things. You learn a lot about, there's a lot of biology. There's a lot of, we have people with wildlife biology backgrounds, who, kind of are working on these sorts of things. And we get into the kind of weird types of things you didn't even know you were going to need to worry about, which is, if you do have a whole bunch of oiled birds, how many of them do you expect to find? So if you find 500 oiled birds, how many oiled birds were there actually? Did they act, because if some of them were at sea, like if it's a type of bird, so you need to know the avian biology, you need to know, well, are these the types of birds who were at sea? And how many of them would wash ashore? How many would you find if you went out and did a study for them? Or are these marsh birds? And, yes, they're all on shore, but they're really hard to find, or things eat them. And, we actually went out, we had groups that went out and did whole studies to figure out like how long carcasses last. Like how long do you think that bird is going to be there, and how much of a chance do you actually have to go find it? We also then come back to the laboratory and think about how things, so we work with toxicologists and chemists who are working in the laboratory. In this case, they're, exposing eggs to oil samples and seeing what doses, looking at dose response curves. So how much oil in the water in order to kill baby fish, to kill pre-baby fish, to kill the fish embryos. And so these are, in this case, like this LC50, this is a lethal concentration of 50% of the animal. And that's kind of a key thing we look for to understand. And again, all of this is to help ourselves paint a picture of what has gone wrong so that we know what we need to fix. Keep an eye on the time here too. I'll kind of try and get through some of this quickly too. There's also about the human side of this. So natural resources, but there's two parts to it, which is the impacts on the resources themselves, and then also the impacts on the human uses of those resources. So recreational fishing, kayaking, swimming, bird watching, all of these types of activities that utilize natural resources are part of what natural resource trustees can get compensation from responsible parties for. We also spend a lot of time thinking about how long it's going to take to get better. So this is called the recovery path. Some habitats get better faster, some habitats get better, take a lot longer. Maybe there were very rare species there and it's going to be hard to repopulate. But for us, that's our end goal, is thinking about how do we actually do then what we call compensatory restoration. So if you oiled that, you had an oil dune and, you killed off everything that was living there for, 2 years, and now it's come back and it's going to take 20 years and you've done all those calculations. But then what we also get to do is say, that's great. Okay, glad you fixed that. And now you also need to make, 10 acres of, you need to fix up 10 acres of new dunes in order to provide compensation for that period of time when we didn't have the resources that we were supposed to have. So a lot of where our work ends up is identifying what these sorts of restoration projects are. And so kind of where this ends up is at dollar values. For the most part, these are dollar values that have to be spent on restoration projects. So this is kind of an important part for all these federal rules, regulations we're talking about. All of these recovered damages in those cases must be used for environmental restoration that has a nexus to the injuries that actually occurred. So in this case, the Deepwater Horizon oil spill, there were $8.7 million in these natural resource damages that are going to be used for restoration projects in the Gulf of Mexico. These next two cases here are actually state-based cases, or private and kind of cities and things suing. And so they have more leeway in what they end up spending that money on. The Gold King mine, that river we started talking about, the Orange River that you saw very earlier on. In this case, so far in the environmental damages there, that was done under a mix of, there's been a number of settlements, but the cases were brought there under tort law and under CERCLA by the state of New Mexico and by the Navajo Nation. And together, so far, those two entities have recovered $89 million, with about 22 million of that specifically for natural resource damage restoration projects. And then the rest of these are kind of oil spills, and these are kind of smaller events that have happened, just longer than. So there's a wide range of these things, but there's a lot of work, a lot of restoration and work that can be done with these. You want me to end at the half hour? Is that it, Erica?
Yeah.
Okay. All right. I will give you like a minute about me then. So just kind of, where we got here, you know, I think this is kind of how this is a lot of times like this was kind of the big thing for me. Like, I don't know, you have to figure out, this is the main thing, actually, the main theme of what I have with this is that you just need to kind of like talk and explore and figure out what's important to you. And, you know, like that's the biggest thing with this sort of policy work is how does what I know and what I'm interested in, you know, line up with the real world. So I was about, I mean, I was a high school student when this happened. I was 15 when the Exxon Valdez grounded off Alaska. And I was a junior naturalist at my local nature center. I was really, and it made a huge impression on me. I went to the Research Science Institute the following year. And, you know, this was like my fact. I was from Wilmington, Delaware. This was my fact about my hometown, that, you know, the Exxon Valdez, you know, had been renamed and was now registered there at the Port of Wilmington. And this is also what drove the Oil Pollution Act. So in 1990, just a year later. So, you know, if you think about how slow government works, this was a very quick thing that happened there. A year later, they passed the Oil Pollution Act. And this really kind of is what got me started. So just, you know, kind of my individual path, that kind of got me started. I was always interested in chemistry. As I said, from Wilmington, Delaware, where I grew up. I was a child of DuPont. So this was kind of you know, chemistry was just part of life there. I went to WashU, studied chemistry and biochemistry. One of the main things I did, well, just kind of things that are slightly outside the normal that I think were very helpful, was I did what they at the time was called a text and tradition program that was particularly encouraged, I think, for like science people and stuff to spend some time in the humanities. But it was really kind of an in-depth place to think about the world, about how people fit into it, how we create rules for our societies, and just really, you know, got me thinking about regulations and what's good, and, you know, does tort law work better than environmental law, and how do these different types of things work? I also have done, like, I tried to spend summers and, you know, research doing as many different things as I could. So I worked in the Delaware Senate. I worked for the clerk of the court. I did summer research programs, which I think are the best thing you can do in college. I worked in marine studies one summer and in pharma one summer. They, you know, just kind of, and to do them not through just 3-year college, to meet a whole new set of people. So, you know, it's, you know, university is great, but you want to then go meet people in a whole bunch of different places, because just the more people you can talk to and hear about their stories and what's going on, that's it. So for grad school, I, again, studied chemistry as well. But while I was there, I snuck into the technology and policy program. So I went to MIT just as a chemistry student. And then once I got there, I just kind of started taking classes in the technology and policy program as well, and like wheedled my way in to their facilities and what they had. I taught a whole bunch of different chemistry classes while I was there. And as part of the technology and policy program, I also had access to their urban studies program, which really talked a lot about how, you know, kind of how cities and people interact with the natural world, and, you know, kind of environmental justice, injustice issues here. That was in the Boston area. You know, just kind of going into communities and understanding what their relationship was with green space, and how limited certain things were, and how important, you know, environmental issues really were. So at one level, that's kind of my big thing. Just figure out what you're curious in and go learn about yourself. There's a ton of options out there, and go for it. I think that's it. And don't have to have your kids build Lego models about oil spills like mine always learned to do.
And that is so phenomenal. I remember being in 8th grade when the Deepwater oil spill happened, and just like watching it on the screen and us all kind of like collectively reacting to that. And so one thing that I'm so curious about as we were going through this presentation is like impact of all of these like regulations and scale and what that looks like. So we're going to dive really, really deep into that in the question and answer session. But I want to pass it over to Cecilia Younger. I am so excited for this upcoming presentation, and thank you again so much, Anne.
Thank you. When Erica asked me to do the presentation about it, I thought it was like really, really interesting, just to be able to talk about my experiences and what I do. Basically, I'm a statistician. And what I do, I take data and I create stories so that people can use the data and develop policy. And so that is my job. And I have worked in the US and in the Caribbean. I actually really, really love working in the Caribbean because I actually thought that I made an impact. I work with different governments and different governmental organizations to examine drugs and how it impacted society. And so I want to talk to you really about my journey, how I got there, and then I'll talk to you more about some of the projects as I go through. So basically, I'm an educator, I'm a statistician, I have written a few books, and I'm an entrepreneur. I actually straddle the teaching statistics and decision making with doing it. I do program evaluation and getting more into some arbitration and mediation, which is interesting. But I also just do research, and I do research with companies and different just other researchers. But I am actually support to people in getting their information analyzed. So my story is that when I was in high school, I always wanted to be a surgeon. Well, actually, I wanted to be a vet, but I couldn't be a vet because I was allergic to animals. It killed that. So then I wanted to be a surgeon. But then I realized when I was in undergrad, one, that I don't like working with cranky people, and I don't like working with sick people. And so when I was in San Diego, I was taking biochemistry, and I also realized I wasn't that good in science, but I was good in math. And with my math, I was actually able to get more into public health and statistics. And like Anne was saying, with she was doing internships. Well, I got to do some internships in public health, and I really, really liked it. So after I finished San Diego, I wanted to go and do biostatistics and public health, but I had to take a year off. So I went to UCLA, and I got to learn more about public health field and knew that I really wanted to do it. So I went to Tar Heels, Chapel Hill, and looked at, just got into biostatistics, but I really got more into the medical part of biostatistics. I went to pharma after that. So I was working in pharmaceuticals, and I'm looking at cardiology and dermatology drugs, which was fun. But I also knew that I really wanted a PhD. I wanted that terminal degree. And that was mainly for me because I just wanted to seem credible. So I got a PhD in measurement and statistics, and that's really a fancy word of just saying educational testing. And so that I went to Iowa for that, and then came down to St. Louis. And so when I started my career, I was a professor. So I pretty much have always been in academia all of my life, and I've enjoyed it. And I've enjoyed it for a few reasons. One, because I get to teach, which I never thought I would like to do, but I do. And I also get to take everything that I've learned and what I'm doing in my practice and consulting, and I bring it to the classroom so that people can actually learn from it. So I was at St. Louis University for like 5 years, and everything was going fine. I was working with some physicians. I was also working in the nursing school. Note to self: when you are starting out working, find a mentor, find someone, a sponsor, to actually help you maneuver, navigate where you are, because they will fight the battles for you and tell you what you should do and what you shouldn't do. So after 5 years, the college actually brought somebody else in to, not to replace me, but to be my manager and replacing my previous manager. But that person had the same degree I had, and there wasn't really a need for us. So then I went out and I started consulting. I actually had a really good time for it. So some of my projects, I worked for some hospitals and evaluated their programs. One was looking at creating play spaces for kids. But what I did is not just statistics, but I'm part of a research project. So I'm actually looking at how people go into a community and figure out the best way to do things. So as a statistician, you have to know how to critically evaluate things. and critically look at things. And so as a program evaluator, what I actually do, I went in and looked at how the project was being implemented, but also looking at the expected outcomes, which was building a playground, and the unexpected outcomes are which when the neighborhood does not accept the playground and they kind of reject it, they don't use it, they don't clean up after it. And so that's kind of what I do. I actually look at all of these things and report back to the funder and saying this works and this doesn't work. That's kind of really roundabout kind of parts of what I do. But the other thing that I really got to do as a consultant, I get to work with big companies. And so I was able to work with a financial agency. And with this, I did some creative things. They asked me to validate their hiring processes. So I actually got to talk to the people who hired, their tests that they conducted to see if it worked, and it didn't work. Found out that it really didn't work, and they could just hire anybody they wanted to because they got the same results. But that led me to another project, and that was actually trying to find out what is the difference between successful financial agents and unsuccessful financial agents within the first 3 years. I got really good at it. I got so good at it that I wrote a book about how to build a business. And it's like being bold and driven. So these are like the two things that I've done from my research. And what we did with that, I flew around the nation to really just talk to financial agents and see what it was that differentiated them. And then I went back and I talked to other financial agents who were more seasoned and really just fine-tuned what was happening. And so it was kind of powerful for me. I know because I actually talk to people, I do lectures on this and talk to different businesses on how to build a business. But everything that I've learned is not just about building a business, it's also about building your career. So that was really cool. So after I was doing all of this, and then the one thing that you should know if you're ever an entrepreneur or doing whatever, you always have to network and you always have to market. But this project, when I was working for the financial agency, it was I got it through someone who knew me. And always know, don't put all your eggs in one basket. And that's what they told me, because they were my bread and butter client. So after that, I picked up other jobs, but that's just hindsight, things that you should realize that you should always diversify in what you're doing. So once that job left, I kind of went down to San Antonio, and because Hardcore Assessment, they saw me and they wanted to hire me to be a research director for their educational test. So I went back into testing and developed a test for K through 5th grade and how to learn. But I didn't like it. There are things about corporate America that I like, that I don't like, but I also know that being a consultant for a long time is just hard going back to corporate America. So what I did, I actually started writing letters to the Caribbean, because I just said, you know what, I want to go to the Caribbean. And I was there for 8-9 years. And the Caribbean Adolescence was one of the books that I actually wrote because I was doing research with the government. Let me see what, oh yeah. So when I was in the Caribbean, I went to Trinidad first. And when I went to Trinidad, I just really wanted to travel. And I was thinking, oh, it'll be nice because Trinidad's industrial and that I'd be able to go to the beach. I got there. You do not go to the beach in Trinidad. It is 2 hours to drive from where I was living to the beach. So it was short-lived, but and I went up to Grenada and I found a really good institution to work with. And it was the med school, and I actually had a great time. And I always like doing things that I'm passionate about and doesn't feel like. And so being in Grenada, it just didn't feel like work. Let me show you. This is my office. My office, this was the window for my office. So when I looked out, I got to see the ocean. But the really good thing about being in a small island was that I was able to make an impact. And what I did from one of my students in Trinidad, he was like, oh, contact my cousin in Grenada. So I contacted his cousin in Grenada. He was the drug officer in Grenada. So then I just started doing studies, doing drug epidemiology and analyzing what was happening in with drugs in the Caribbean, and started working with the Organization of American States to really monitor and evaluate what's happening in the actual Caribbean about drugs, and what, like the age of first entry, and what drugs were on in the coming into the country. One of the things that I was able to do, I added 4 questions into the survey for the entire Caribbean region, and it was about IV use. And they're saying, oh, it's not happening, it's not here, it's not here. Found out that on each island, it was about 5 to 8% of the students, and these were high school students, were using IV drugs. So with that, different governments actually had to start monitoring it. And they had to start monitoring it so that they can actually develop policies for it. And so it's really nice when you actually see the impact of your work. That was one thing that I did. But also, I was looking at the alcohol policy of Grenada. Their alcohol policy was made, I think, probably 1904. And what students did not realize is that they could buy alcohol. They could drink it on the streets and they wouldn't be arrested. But they didn't realize that. And the government knew that they had to change these laws. And so what I did was help them to see what was happening in the community with the high school students, but also how alcohol was used in the community, just to document what's happening. Because when you're in the Caribbean, one of the revenues is alcohol. So there's a fine line of what you can do and what you can't do when the business is alcohol and tourism. So what we did as a group, and I always say that we all work in groups because I'm just a support person. So I work with the anthropologist, social scientist, epidemiologist together so that we could actually develop a new policy for alcohol. And one of the things that we did do, we got to do focus groups, and we got high school students. We wanted to find out what the meaning of drugs was. And that was really interesting because with alcohol, young ladies would say that they drink alcohol because of stress of taking tests, stress of their relationships, but it was all due to stress. For the gentlemen, they drank alcohol because it was what they saw. And so with that information, the legislatures and actually the police were able to develop strategies to increase the age of first drink, because it's not that alcohol is illegal. We just wanted to increase the age of the first use. So that's some of the things that I've done in Grenada. Other things, because with my students, we actually developed policies for other countries. And one of the policies was child sexual abuse in St. Lucia. It was an issue. And what we did, I had a project with my students where we get data from different countries and my students analyze it and they develop policies. And this one policy, it was taken to legislation in Parliament. It was taken to Parliament so that laws can actually be built out with it. Another one was driving under the influence in Trinidad. There were no laws about or protocols of what you do when there's an accident. And so that's what we did. We get data, actually live data from a country we analyze it, and then we put it into a story about here's what you can do. Let me see. So Erica asked me, what does my day entail? My day entails so many things because I just don't do analyses. What I do, I do work with my clients. So I work with my students, but I also work with my clients. Because I have a consulting business, I have to go out and market myself. I teach and I do analyses. So it's a combination of all four of these things. But what's really nice is that I go out and talk to people, because when I started as a statistician, being in big pharma, you just didn't go out and talk to people. You could always hide behind these and write reports, but as a consultant, I can't. So I have to work with clients. I really have to look at my image, seeing how I'm getting out to network with people, who I'm meeting, and how I'm actually bringing business to me. And I think that doing this, it gives me different hats, but it actually makes me look at the world differently, because in my analyses, I don't just look at statistics. I take what's happening in the world, what's happening with my clients, but also as you're going into college, and I think Anne said it, that you need to take more classes, and you do, because you need to bring everything that you learn into telling your story as a statistician in writing your reports. I remember when I first started writing, I had an editor, and she had, I think, a philosophy major. She was bringing in philosophy into my reports, and that just made me open my eyes. I'm just like, wow, I really need to include the psychology, the sociology behind what's happening, and it brings life to the numbers. Because to be honest, if you're looking at numbers, they're mind-numbing. But what you do need to do is bring life to those numbers, and you do that by bringing in context, and you have to bring in the background from it. I think the one thing, if you ever want to be a statistician, the one thing that you can do is have a well-rounded background. Go into liberal arts, and you see how the world connects, and you can bring that into the numbers. Here's another. When I was in Grenada, this is what I got to look at every day. So to be successful, I think it's you need to be able to think critically, and to lay the foundation for whatever you want to do, and prepare for the future. I always like to tell my students that you need to lay the foundation to be able to do other things in your working life. Because I think right now you're going to go into like 2 or 3 different professions. Lay a firm foundation to be able to jump off to doing other things that you enjoy. But also be civic-minded, because what's happening is, as you are developing your careers, people are watching you. They watch how you volunteer, how you contribute to your community. And it is really important to be able to show that you're out there and doing something positive, and how you network. Your network is just doing things that you enjoy doing, but also knowing that you're being looked at. You are always being watched. And that's how, if you're going to be an entrepreneur, that's how you actually get clients, is by networking, but also showing people that you're dependable and reliable. Find a mentor and sponsor. That is so key, because a mentor and sponsor will tell you what you should do and what you shouldn't do. For example, you shouldn't wear that lavender outfit to a meeting. It's inappropriate. That's what a mentor and sponsor does for you, but they also speak on your behalf so that you can actually navigate and excel in your career. Continually learn new things. Always be on the lookout to learn something else, because whatever you do, wherever you go, you'll be able to use it with whatever you're doing. You never know where it's going to take you, but also have hobbies. And I say have hobbies because you need to have a more balanced life. And I think a lot of people, they don't really think about that. With hobbies, if you're an entrepreneur, your hobbies will actually introduce you to other people so that you network, but also it gives you an outlet of things to do. And it makes you a more rounded person because you have something else that you can talk about. So with that, any questions?
I absolutely love the overlap of civics and policy. I think that Anne and Tim touched on like the environmental aspect of it, and we got a really we got a really wide array of connections with you. So one question is advice on making connections when starting a small business. So gaining clients and partnerships. I think Anne and Cecilia both have insight on the consulting aspect of that.
When you're starting out in doing a new business, the one thing that you can do, I mean, what you really need to do is look at your civic organizations to join, because there you're going to get a lot of contacts in what, and this is what with whatever you do. But what you want to do is you don't want to look at meeting people with the intent of getting business. You want to meet people so that they know your name, because if something comes up, they can refer you. So for example, I was on the board of a tennis club, and I got to meet a lot of people. But you know what? I also weld. So when I was telling them that I needed space welding, someone's like, "Oh, I know so and so space." It's meeting people. They know what you do. They know they want to help you. Everybody wants to help someone else, but they can't if you are not reliable and credible in their eyes. They will not open their network to you. So when you're opening up a business, you need to get out. You need to talk to people. You need to and it's a variety of people, but don't expect business right away. It comes. You just have to put in the legwork. And do you have something?
I mean, I guess I would just say too, is that, I mean, kind of on the conversation, sometimes you don't have to do it all yourself either. I mean, just because you want, like I never worked on my own doing the types of work that I do. Like I joined a consulting firm, at the time it had like 60 people. It was, they did the types of work I was interested in, and that gave me that space. That was kind of like a built-in network. Like that was like the built-in like group of people, group of clients. And I did, so kind of cheating maybe, but I didn't have to do a lot of that legwork. Like it all came naturally. So, it's like now when I'm like my clients and the people, so it's like, yes, because I was going to say that's like the add-on, like everything's like do that too. Like that's how you meet the new people and expand and do all those things. But don't, and maybe it's kind of it's like, don't feel like you need to do it all yourself. Like it's fine. You are still an entrepreneur, even if you are working with other people in a job. Like you can still be building, your skills and what you want to do.
I know that it is coming up on 6, but if one person can comment on finding a good mentor and any other questions, if you email me, I will get in contact with our speakers and get a response to you.
Finding a good mentor or sponsor, if you're in an industry, it's looking for the person that you connect with, 1. 2, that has walked what you're trying to do, so that they know like the subtleties of how to help you. And it's getting out there and talking to people and finding out who you think can help you, but also who wants to help you. I think that that's even more important. I know when I was talking to so many financial agents, they're saying, well, I was assigned a mentor, but the mentor may or may not want to be there. That person has to want to be there. They have to want to help you. And when you go out and talk to people, you find those people.
And I'll just say my one little piece too, is it doesn't have to be the one perfect mentor. Like you don't need to find one mentor who can, do everything for you. Like, you might have one mentor who helps you think about how you set up a business. You might have another mentor who, is the person who can helps you think about how you want to organize things or where you want to go to school next. Like that you can build kind of a perfect mentor from different people as well. It doesn't all need to be, kind of the one, one unicorn. Though that if you can find somebody who is like That's great.
But yeah, no, I think that having a support network is great because you can bounce things off of different people so that you can make the best decisions for you.
Yeah.
Fantastic. Again, if any students have questions, they can, I know you guys both provided your email address, or they can email me. I am so excited that you were able to speak today. I love putting these webinars on. I think that it's a phenomenal career planning opportunity, and thank you so much for coming and speaking to students.
My pleasure.
Yeah.
All right, I'll see you guys.
Thank you.
Bye.
Thank you. Bye.